we have, other than radial loading, what if we have axial loading too? There's a way you can combine axial and radial loading into a single value f, and then use that in that formula, f times L raised to 1 over A. So let's see how to do that. So this section is 1106. Combine loading. That would be radial and thrust. Okay, so thrust is also axial loading. Okay, so we saw the formula is F L raised to 1 over A is a constant. Okay, where this is radial loads. So assuming that there's only radial loads, then you can use this formula. But what if the bearing is, so assume there's a bearing. If the radial load comes this way, the axial load, so assume that there's a shaft which goes in, shaft. So the axial load will come this way, so along the axis of the shaft. And so we want to basically use that formula, but how do we combine FR and FA into a single F, which can then go in this equation? So how to combine FR and FA to use in the formula. So one guess is, you could just take since they're 90 degrees apart, you could just take the sum of squares, square root of sum of squares, which we normally do for the resultant, and use that, but that's not a good way. It actually doesn't really give you what you wanted. So what people have done is they've resorted to experiments to figure out what's the best way to combine the loads. And that plot is actually shown over here. So what we do is we define what is known as an equivalent load. Okay, so this is how we'll combine the two loads. FA is the axial load, and FR is the radial load. So we'll define a factor V, and that V is called the rotation factor. One and 1.2. One you'll use if inner ring rotates. So there are two types of bearings. One is when the inner ring rotates, so you'll use V equals 1. And if the outer ring rotates, then you'll use V equals 1.2. Okay, so what is going on is, once we've defined this, what we do is we make a plot of the equivalent load versus V times FR and FA divided by V times FR. And that plot is shown here. So that is the first one. This is your y coordinate. And then here we have the x coordinate. Okay, so this is basically an experimental plot where these two things are plotted, and you can see that they actually fall in a nice fashion where it's more or less flat on the left side up to here. Like those circles are the data points, and then it slopes up. So we can explain this line, which I just drew with green, by using two equations. One equation for up to this point, which this point is denoted by x equals z, and then beyond x equals z, you have a line with a slope. Okay, so Okay, so as I said, there are two parts to the line. Let's call this part 1, and this part as part 2 of the line. And I'm going to write equations for both parts. So the first part, we can see that VFE divided by VFR, is equal to 1. Okay, and that happens till the x coordinate. In this case, the x coordinate is F divided by V times FA divided by V times FR is less than equal to E. So this is the first part of the curve. And for the second part of the curve, we have an equation of a straight line. The straight line is such that its slope is, they've denoted it as y, and then its intercept on the y-axis is denoted as capital X. It's a little bit confusing. The y-intercept is denoted x and the slope is y, which is, bear with me, because this is how it's used in the later on when we have a table which actually gives you the values for x and y. So we can write the equation for part 2 as follows. We have FE divided by V times XR equals capital X, okay, that's the intercept, plus capital Y, FA divided by V times FR. And that is true when FA divided by V times FR is greater than E. Okay, so what does this look like? Well, it looks like equation of a straight line. So this term over here is y, right? This is y. This thing is x. So x equals, if you remember, the equation of a straight line is y equals c plus mx. So this is the intercept, and then the slope is m. Right? So y equals mx plus c is something which is well known, a formula for equation for a straight line, and that's only true when FA divided by V times XR is greater than E. Okay, so what you can do is you can actually combine these equations. So we can combine both these equations as a single equation. So let's do that. The equation is FE equals capital XI V times FR plus YE was YI times FA. What it is done over here is essentially you're dividing throughout, you're multiplying throughout by V times FR, and so you will see that you'll FE left on the left side, and then X, Y. I wrote them as XI because I'm trying to describe both those equations. So I will have value of X1 for the first part and X2 for the second part, same for Y. Okay, so here I equals 1. That will be X1, Y1 for FA divided by V or less than E, and I equals 2 or X2, Y2 for FA divided by V times FR is greater than E. So that's the formula you want to remember. It's slightly more complex, but it's one formula for both those parts. Now the question is, how do you compute xi, yi? Those things come from experiments. These dots, the circles came from experiments. So you need to basically curve fit these points using the green line I drew there, and then find the constant. So there's a table in the book which gives you these values. Here is this is for region 1, x1, y1, This is for region 2, x2, y2. Okay. It also gives you E. And then the key information you need in order to figure out E is you need to know FA, the axial load, and C0. C0 is the constant static load, which is given to you. It's a basic static loading. C0 is a new thing here. Constant. Okay, so that's one part. That's how you go about figuring out FE, right? That was our whole purpose. So this, we were trying to compute. Why were we trying to compute FE? Because once we know FE, we can use that equation F times L raised to 1 over A equals constant in order to figure out the life. Okay, so that's one piece. The other piece of information, which is how do you choose ball bearings? This is the bore, the outer diameter, width, and then a bunch of parameters for the bearing. So depending on the size of the bearing you want in your application, you can then go ahead and figure out things like C0, which by the way is needed here. You can figure out the C10 rating, and this is for the deep groove bearing, and then there's similar non-triangular contact bearings. So there's two of the multiple bearings we have. Just picked one particular table. So that's it. So let's see how to use this new knowledge on computing equivalent load and solve a problem. Okay, so an angular contact ball bearing has an axial load. Let's just put things down on what is given. So FA is given. It's 400 lbf. Radial load is also given. That is 500 lbf. Applied with the outer ring stationary. The key information here we get from that word stationary, outer ring stationary, is that it basically sets up what V is, and for that, for outer ring stationary, V is 1. Okay. The basic load rating C0 is 4450 lbf, and the basic load rating, that's the static load rating, this is the C10 rating, is 7900 lbf. Okay, our goal is to estimate the L10 life in hours. The L10 life is given by this abbreviated L10. The other one is the L10, which is in revs, revolutions. And then we also given the speed, which is 720. Okay, so the key thing here is that this particular bearing is subjected to two loads, a radial load and an axial load. And that's why we need to compute an equivalent load. And then once you have the equivalent load, then we can go ahead and solve for the L10 life. So that's an extra step of computing the equivalent load. Okay, so how do we do that? Well, let's look at the single formula we've seen so far. The formula is this right here. Okay, so what do we need for this? We need to compute, clearly we need the ratio E. Once we get E, we can then figure out what these constants are. And once you have the constant, we can find the equivalent load. Okay, so then how do we get those? How do we get E? Well, there's a table which gives us E right here. Okay, so this table gives us E. So then how do we get E? Well, we need to compute this. Looks like we need to compute this factor. FA divided by C0. Okay, both of these things are given to us. We're given FA, they're also given C0. So let's compute FA divided by C0 first. That will help us to compute E, which in turn will give us whether it's x1, y1 we need or x2, y2. And then that will give us FE. So like probably 4 steps. Let's do that. The first step is compute FA divided by C0. Okay, so FA divided by C0 is going to be 400 divided by 4450. That is 0.09. Okay, so let's take that 0.09, go back to the table. Zero, 2, 0, 4, 0, 5, 7, 8. Okay, so there is 0.84 in the 0.0110. Okay, we are looking at 0.09, which is now in between these two values. So what we'll do is we can make a guess of what the value of E is. But since we're given two values, let's assume that between those 2 points, the equation, it's basically a straight line between these 2 points. So we can sort of assume a linear interpolation and get a value for FA divided by C0 of 0.9. So I'm just going to pick this up from this table, write it down, and then interpolate. So let me write that down here. So let us interpolate in order to compute E at FA divided by C0 equals 0.09. So I'm taking those values from the table. So we have from table, it's 11.1, 0.084, 0.11, and then the 2 E's are 0.28, 0.3. Okay, so let's now interpolate. So it's basically fitting a straight line between those 2 points, between this point and this point. And so the equation is E minus 0.28 0.28 minus 0.3. And then our FA divided by C0 is 0.09 minus 0.084. And 0.084 minus 0.11. So what's going on here is, maybe this is easier to understand. We assume a straight line. The coordinates of this point, let's say are, let's say this is X, this is Y. So 0.084, 0.28. This is 0.11, 0.3. And we're interested in knowing what value is at 0.9, 0.09, and E. Right? So fitting a straight line, you just take the ratio of the values. That's how I got that equation. Okay, so what that comes out to be is, should be very close to 0.29 actually. So it's E equals 0.2846, which is about 0.285. Okay, so we've now computed the value for E. So let's go back. So we got a value of E here. We've computed that. Now we need to identify if it's this X is what we want, X1, Y1 or X2, Y2. For that, we need to figure out this ratio, FA divided by VFR. So next step, third step. Let's compute FA divided by V FR. FA was 400. V we saw was 1. Outer ring is stationary, gives V equals 1. FR is 500. So that is 0.8. So it's 0.8. So we have 0.8, and what did we compute for E? E was 0.285. So we see that from this, we see that FA divided by V times FR, which is 0.8, is greater than E, which is 0.285. So if we go back here, we see that we're in this region. Okay, so we need to use x2, y2, not x1, y1. Okay, so moving on, we are interested in these values. Now again, we have the same issue, which is there's x2. Well, there's x2 is the same, 0.56. So there's no problem with that. The problem is here where we have 1.55 for let's say E equals 0.28, and it's 1.45 for E equals 0.3. So what we need to do, or sorry, at 0.084, it's 1.55, and 0.11, it is 1.45. But we want to figure out what is the value for FA divided by C0 of 0.09, which means we again have to interpolate. Okay, so we'll take this table now, these values, FA divided by C0, and take this thing, x, y2, and then interpolate. We don't need to interpolate x2 because it's constant, it's 0.56. So I'm just going to write this down again, so that we can easily use that to interpolate. One thing I forgot here is we need to use x2, y2. So let's plug that f2, x2, y2, and write it down here. Number 4, FA divided by C0, x2, y2. So we have 0.56, and this was for 0.084.11. And then we saw that was 1.55, 1.45. Okay, now, as I said, we are interested in a value which is in between here, 0.09. So we are good with x2 because the same. We want to compute what y2 is, and so we interpolate. Interpolating. So this time maybe I'll just draw that line, makes it quite easy to write the equation. So this is our straight line, which we'll be using for interpolation. This point, let's say, is 0.084, and then 1.55. So I wrote this in this coordinate. Then this point is going to be 0.11, 1.45. Okay, that's the second point. And then we want to figure out what is the value for at 0.09, what is the value for y2? Okay, this is unknown. So fitting a straight line to these points, all you have to do is take the y coordinates or x coordinate, it doesn't really matter. So let's just take the y coordinates. So 1.45 minus y2. Okay, so I took this and this. And so correspondingly, I need to take the x coordinates. So 0.11 minus 0.09. Note I took this point and this point in my equation here. Don't take these two and then the third one. It should be the same. It should be proportionate values. Then we'll take this value and this value. You could potentially take this one and this one, is up to you. Just that if you use the first and the third one, then you will get a numeric value. That's why I'm using the first and third. So 1.45 is the y value. Take the corresponding y value here. And then we have 0.11 for the x value. And then the x value here. Okay, so we can solve for y2 because one equation, one unknown, comes out to be 1.5269. Let's round it up to 1.527, and clearly x2 is 0.56. Okay, so we've computed x2, y2, and now we're all set to compute fe, which is this formula. Good. So fe is x, in this case, x2, VFR, y2, fa. So number 5, compute fe, x2, VFR, plus y2, fa. So fe is, I'm going to sub in the values now. I have 0.56 and 1.527. 0.56, V is 1, FR was 500, plus Y2 is 1.527, just computed that. FA is 400. So solving this gives me 890.8 lbf. This is our equivalent. Okay, the final step is using the equivalent load to do the computation of the L10 life. So let's write down the formula for L10, and then we'll just do substitutions. So the formula is F times L raised to 1 over A is a constant. So FR, LR 1 divided by A, FT, LD 1 divided by A. Now, what do we know about this problem? We know C10. Let me just copy this. Okay, so this is copied. So FR, so C10 is given, FE is computed. So the rated one is the unknown. We have FR, LR equals, now I'll substitute for FD, I'll put FE. And since we're given the L10 life, we'll just put 60 and 10, and 10. So in this case, we're interested in computing L10. That would be LR divided by 60 and 10 is to A, FR divided by FE. I'm just moving things around. I did a mistake here. So sorry about this. This should be, I'm going to pre-multiply both sides by 1 over A and then do the substitution. That looks right. Okay, so let's substitute. So LR, so now LR is the rated life. Now we know that the rated life for roller bearing is and this is in revolutions, is 10 raised to 6. Okay, that's the standard definition. 60 and 10, that's 720. FR is it's given somewhere. It's FR, yeah. It's a C10 rating, so 7,900. FE is something we computed. It's 890.8. And then A is 3 for ball bearing. For all. Okay, so then just crunching numbers, the L10 life is 1614 5.7. Okay, that's it. That's the last question. So I have a homework which is based on all these things we talked about in roller bearing chapter 11. And then I have one question on keys. This part is not in your exam on Wednesday. So we have 5 classes left, and the exam is on May 2nd, I think.